I think. Are we up? I think we are. There we go. All right. I just need to sort out a drink. Then I'll sort up. Sort up? Yeah, long day. I'll set up. Start up. Hal.
Hello, Dino.
Didn't hear Hal. Did you hear Hal? I didn't hear Hal. I couldn't hear a thing from Hal. Hello, Hal.
Hello, Dino.
Oh, and I know why that is. It's because I was just working on a song with headphones on and I need to turn my studio speakers on. So I can do that. Home automation. This shortcut here connects to my home automation. Turns on the speakers. It's just, yeah, so that I can unplug them when I'm recording so I don't get feedback. Let's try that again. Hello, Hal.
Hello, Dino.
Oh gosh, loud. Oh, I turn off my little things here. Off. I said, right, there we are. Fine. Hal, initiate Unreal Restart Protocol.
That's a mouthful. You should have used Boost.
Be right back, getting some water. It failed. Didn't it? It failed. It failed to open up Visual Studio. And the reason for that is because this started up not at 150%, which is set up this monitor. Because this monitor, yes, otherwise it's too small. And my feeling is that's the reason why it failed to open Visual Studio. Let's try it. So where are we at today on the... Yes, I'm still working on networking. Well, no, I'm done with networking. I mean, not done, but research part is done. So essentially the back is broken of networking. I'm still learning Unreal, but the really important thing that I'm doing now is working on, well, Nugget window. So, spawning, and manipulating actors. The new topic. So these are all my experiments. This is where I got to with my network stuff. I can run this like so. What happened to the down here we have the output window. If I start a command shell, Sigwin command shell here, and I can use the netcat command, connect. Yes, it doesn't print connected anymore. Now when I type things in here, they appear in the log. Which is nice. So what I want to do, whole point of this thing, if I try to connect again, yeah, and it only at the moment only works with one time connection and can't reconnect, but so what I want to do is to be able to send commands to create objects in the scene and manipulate them. So now I've got to sort of figure out stuff. I've figured out a little bit, but well, we'll need a scene, I suppose. And this one thing that really confuses me is I go and say a new level. Let's start a new level, Unreal, because I'm learning Unreal at the same time as I'm doing this. So I'm going to go in here, and we don't know what kind of level. We could go for a VR basic level. I love the way that when you're these menus, it's a new menu, a new level, and it immediately spams you with stuff like, you know, do some VR, immediately do time of day, or go for the empty level. What I'm trying to do. This action, yes, terminate my play session. This is an empty level, and suppose it's so empty. Unlike, it is so empty that it doesn't even have a light. And up here we can see that the scene is pretty much empty. It's just this thing. That's for the world settings. Okay. Good day. Good day, Mike. How's it going? Terrible Australian accent. My accents are famous for being terrible. Well, no, they're not even famous for that. Can you call me Dini? Yes, Garcia. Absolutely. You can call me Dini if you want to, old Gas. Can I call you Gas? So But then I hit play, as you know, eventually you will. You hit play, and then this happens. Suddenly there's a camera actor, a default PORM, a game mode base, a game network manager, a game session, a game state base, a HUD, a particle event manager, a player camera manager, a player controller, a player start, PIE, and player state. And scene still. Can't see anything. Where did all these things come from? It's like, can I just sort of like, can we just keep it simple for now? I find it really annoying. It's like, I don't need a HUD yet. Because, oh well, the HUD is there when you need a HUD. It's there, it's ready. But of course it's there and it's ready. But I bet you it's not going to be easy to use. Probably put something up on the screen. Put some text up on the screen. And there it is, inviting HUD. And then usually there's a world of pain. Well, normally that's the case with game engines. I don't know. I'll find out when we get there. Garcia minion. Garçon. Garçon. Servant. Is that what garçon means? Yeah. That's quite clever. French. So many things are. I don't know why I said that. It's just... Except French fries. They're Belgian. Yes, we live in that kind of world, if you hadn't realised yet. So... So I think what it just annoys the hell out of me. I mean, don't give me stuff I'm not using yet. So I suppose from here it's probably a great uphill struggle. I mean, I could say, give me a light. I'm just curious. I've got a light. L-A-G-H-T. We'll get a light. A directional light. My favourite light. My favourite light because it's a simple light. You can't drag into the viewport. You can't drag it into the world outline. Why? That's really annoying because then it's like you put it here and it appears in some kind of 17,000 miles over there or something. Well, normally that's what that would do. Maybe in this case not. So right, look, where's the directional light? Why? You give me like VR level, but what about where this is located? The transform of this. Why can't I see that? I'm going to close the world settings a minute. I'm going to go up to this window and search for the... Which one is it? Edit modes, editor modes, details, details 1. Yes, that was a good guess. Put it here. The directional light is at coordinates 990, 243. It's like some random blooming... Right, so what I'm going to do is reset to default. Oh, that's interesting, but it won't let me reset the rotation to default. Very interesting too. And the scale. Why is the light scaled? I don't like that the light is scaled. Why? I scale. What does it mean to scale a directional light? But there's a light shining in this direction. It's already infinitely big. Like, if it's shining this way, it's infinitely big that way and this way. So it's like, what? Then I'm tempted to change it to 1, but I do want to have it movable. Reset to default. That's a real time saver. Yeah. I'll leave that alone. The rotation couldn't reset the rotation for some reason. So I'll have to type that in then. 0, 0, 0. 0. Of course, very important when you make a 3D engine that you don't use Euler angles. Hang on, I can reset to default now. Fascinating. Ooh, I can't undo. I'm learning so much here. Hang on. Where did that go? Oh, click here. Right. Yeah, I can't undo it. All right. Well, I have a light and I can't see the light because there is no light. There being no light, I cannot see the light. I'm not beginning to see the light. Okay. Oh, it's running. That was the problem. Now there's a message log here. It'd be nice if I could dock this on. Oh, I can't dock it here. Can I dock it there? Yeah. No. Oh, it's mobility. Some issue about something or other. Oh, I added the light when it was running, so that's similar to Unity. That was lost. I'll try this again. Let's take our directional light and sort of put it somewhere, and then yeah, reset the transform. Now again, can I undo that? Right, so I couldn't undo because it was in play mode. So here's weirdness. It's like I can't reset the rotation. Or maybe because 0, 0 and 45.9999996 is in fact the default value. So what I'll do is try setting this to 0 to test this theory out. I set this to 0 and the little arrow appears over here. Euler angles are never okay. Euler angle. That's the funny thing, is that, you know, you could have used quaternions on really old hardware. Just the idea of using quaternions hadn't really existed. In the end, it's a mathematical equation, you know, just a formula you put in. You could use quaternions on a PlayStation 1. It's not reset to default. Yes, the default value is minus 45.9999996. So glad we cleared that up. Apparently, if you hit spacebar, you can switch between the different modes. I quite like that. I can change the angle of my directional light. Now, the directional light's probably not actually doing very much because there's nothing to light. So I'm going to change its position vertically, not that the position of a directional light really matters, but just from the view of sanity when inside the editor. Then I'll see what I can do now. Plane. We're going To make it plain, I make a plane. So that's actually encouraging. I have this little tiny thing here. This is definitely, I mean, it's a little bit small, isn't it? It seems a little bit small to have the grandiose title of a plane. It's more like plate. It's a quad. Mind you, it's difficult to get a sense of scale here. Right, so if I scale the ooh, I can do that. Okay. The units in Unreal are in centimeters, whereas in Unity they are meters. So 100 centimeters is 10. 100 centimeters is a meter. Sorry. This plane. Well, I don't know. I don't know what the size is. This a 1 centimeter plane? Difficult to say. Now, what I want to do is just check units here. I wonder if I can change. Well, if I click this. Oh, top. Ah, what a relief. Oh no, wait a minute. Not really, because I can't. Oh, yeah, I can see the plane. Ah, but this mode that allows you to change how you're going to manipulate the thing doesn't work when you're in this camera mode. Something. I can rotate. What? Oh, rotate. That's great, but I want to. Oh, now it works. It's just all random, you know. It just things work sometimes they don't. So this is all normal. everything I'm used to in video game development. I basically have never. The tools are always painful. What I want to ascertain is the dimensions here. Well, I suppose I can do that by changing the location of my plane. The Z, which is the Y. Yes, they mean something. They mean a lot. The units in a game engine mean whatever you want them to mean, but that means a lot. The problem is that it's actually interesting. I thought I saw some code somewhere for Unreal which also had the same bug that exists in Unity with regards to normalization. The fact that the normalize function in Unity, the normalize function that everybody uses or normally uses, is actually broken. And there are many people in a state of denial about this, and they say, no, it isn't. It's designed that way because mathematically you can't normalize a vector shorter than this thing, and it's actually not true. And I followed. Oh, the story is hilarious because it's a great example. It's a great example of how things that are broken can become standards. But then I found there was a similar code in the Unreal Engine for normalization somewhere. I remember seeing, and I was going, really? Done the same thing? It doesn't exist in the new maths library for Unity, by the way, and I have studied the thing to ensure that in fact it is a waste of time. This little check that says if the vector is shorter than a certain length, then just return 0. Does it return a 0 length vector? But anyway, there is a point to this story. Because Unity has as its units, 1 unit is a meter. If you check for the vector length 0.0001, whatever it is that you check there, it's about a millionth of a meter or a thousandth of a millimeter. And it sounds like, well, who would ever have a vector that small? But the funny thing is that if you work on a millimeter scale, which is how I discovered this originally, working on making a model, I had to make procedural mesh generation and deformable mesh in real time in Unity at the scale, at millimeter scale, for the purpose of VR work. So millimeter scale, and when you're in VR, a millimeter, if you're in VR and you're simulating things which are you're manipulating with your hands and so on, a millimeter is actually pretty, it's very visible. Right? Doing fine work, millimeter, not actually that fine. So you've got this mesh here, and it's the distance between the vertices of the dynamically generated mesh being approximately 1 millimeter apart or so. When I deform the mesh, I have to recalculate the normals. Recalculation of the normals I just used without thinking about it, because none of us think about it. I use the Unity normalize function. The problem is, this is what it does. And I'm going to go just very briefly describe how the new Unity normalize function works. It takes a vector 3, which is, of course, 3 floats. A float being a single precision floating point number. The precision of a single floating point number is approximately down to 6 decimal places. Thus 0.00001 or so. All right. Okay. And so then what happens is it calculates the length of the vector, as of course you must do in order to do the normalization. Normalization, you'd scale the vector by 1 over its length. Well, of course, if you're aware of what that is actually going under the hood, because you know what you're doing. You are multiplying 2 vectors together. Rather, you're multiplying. Sorry, start again. You're squaring the coordinates, right? So, what it does is, because you have to do like x squared plus y squared plus z squared, and that gives you the length squared. So you do that, right? But think about it. If you're down to, you should be all right. I mean, if the vector is a millionth of a meter, right? You could end up with some precision problem there, in theory. But get this. What it actually does is it multiplies them together and feeds the result into the Unity's square root function, which is mathf. Right? Mathf is a wrapper around math, which is the standard library that you get in C#, which works in doubles. So the floats get multiplied together and added together and passed into the square root function in order to calculate the length of this vector. But because of the rules of the way that types work and are promoted, if you have an expression made of floats and the output of this expression goes into a function that takes a double, which in this case is the standard math function of the standard square root, what happens is that everything gets promoted. So all those floats get promoted to doubles. So in actual fact, you have your floats. It converts the floats all to doubles. It then multiplies the doubles together, adds them together, passes them to the square root function. The square root function calculates the square root as a double, and it then casts it back into a float. And then it checks to see if the float is smaller than a certain amount, because of the concern about dividing by that number. So that's all a bit weird, right? If you can see the point there, it's actually calculated with the precision that it could handle it. but then doesn't handle it. There's another point about it, which is, okay, you could say that's when will you ever need to? I'll tell you when you will. When you're calculating the normal to a triangle, and that triangle has its vertices about 1 millimeter apart, which would have been the case in the thing I was doing. So think about it. The cross product requires the multiplication of two vectors. This part, in fact, it's the multiplication of two coordinates of the vector, like x and y and so on, right? Two of those subtracted by another multiplication. So basically, each of the three resulting coordinates, vectors, each of the resulting x, y, z coordinates of the result of doing a cross product involve the product of two of the other two vectors, right? So to get a z, you're multiplying together y and x, and there's something like y times x minus x times y of the other vector, whatever, right? But the point is that that multiplication means you're, in effect, it's similar to squaring the vector. So maybe you can see where this is going. If you try and calculate the normal to a triangle that has its vertices spaced by about 1 millimeter in unity, unless they fixed it, but I don't think they can fix it because it would break everything. If you try and multiply, if you try and calculate that normal, you're in effect squaring 1 millimeter. Now, what happens when you square 1 millimeter? You might ask, or you might not. But 1 millimeter is 0.0001 of a meter. Is that right? 0.01. Maybe I add an extra naught in there. It's 1,000th of a meter, right? So when you square that, you actually get 1,000,000th of a meter. And so you hit into the hardwired limit that is actually unnecessary. You could remove that. Nothing bad would happen. The only time you would get a divide by 0 is if the vector length was actually 0. So if you really cared about that, you would check to see if it's 0, or certainly a number very much smaller than 0.00, about 5 zeros and a 1 after the decimal point, right? So, so what you end up getting is you are trying to calculate the normal to this triangle that's quite small, and the intermediate number that you get, the vector that you get, can be down to 1/1,000,000th of a meter, and then you need to normalize it. So you want to get it back up to a vector of length 1. And then you hit the hardwired unnecessary limit inside Unity's normalized function, and bingo, you get a 0 length vector as the result. So, of course, this is a problem because the rule about normals is that they must be length 1. It does say in the documentation that it will return a 0, but only for vectors which cannot be normalized, which is nonsense because they can be normalized and they should be normalized, even smaller than that limit. So this is just a thing. If you've been working in Unity and ever had all the normals go black, right? You have a model. For some reason, you've got a model somewhere, right? And you're working with it. Maybe you scaled it, maybe but you just try and use this thing, and you find that it reflects no light because you find that it's just black. And that, whatever you do, you can't light the object, and you go and check, and you find that all the normals are length 0, and you're scratching your head. Congratulations, you've hit this problem. And I do wonder about how many people have hit this problem and never found out what it was. This problem hit from 2 different directions in the same project I was working on once. So someone else found it as well, but in a different way. They took a huge model, it was a very large-scale model, and there was a desire to place a small version of that model on a desk. So you've got a big model, and then you scale it down and put it on the desk. think you can see where this is going. The model's quite big, and you scale it down, and you bet now the detail in that model has fallen under the 1 millimeter limit, and the thing calculates the normals for this object now scaled at this point, at this size, and all the normals go black. We never actually proved that that was the reason, but it seems pretty likely to me that it that it is. So there you go. Yeah, but you can't fix it. And I like to say, and I can be a bit cruel with the things I say, but they're not really cruel. It's not cruel. It's not being cruel. It's being real. That's what you get when you develop a math library without taking a great deal of care, mathematical care. It was probably the origin of it was probably some copy or paste that was done. And the fact that I've now seen evidence of it in 2 different engines, it's like engineers, because that's what programmers should be. They should be engineers. Should be rigorous about these things and actually do the math. If you're building a math library or a vector library, something like that, do the math on it. Don't put in a little arbitrary value and say, well, if it's smaller than this, yeah, well, I mean, whoever, when is anybody ever going to need to normalize something that's 1/1,000,000th of a meter? Hello. But Unreal works at 100 times the scale. So there you probably get away with it because you'd need to go down to 100, but it's a square, so it could even be 10,000th. I have to check, but it probably would almost certainly never happen. I mean, unless you were building some kind of game that was working at the microscopic level, in which case, if you were doing that and trying to use real size and not just having a scaling factor in your game, there are certain questions that one should ask of oneself if one has done that, because yeah, I mean, unless you had a game where you needed to scale from one thing to the other seamlessly, in which case you're going to need a whole nother engine, frankly, because you're going to run out of float precision for doing that. You'd need an engine that was entirely running on doubles. But I digress. But the thing is that they can't fix it, I imagine, because all the projects that are out there that rely on this behavior, there'll probably be code that checks, do a normalize, check if the vector is length 0. I don't know, it's just so fundamental underlying the code that there's probably very little reluctance. So my recommendation is and that's what's painful about it. This is why it's mistakes like that. They're catastrophic mistakes that have huge consequences in terms of loss of productivity and production costs, and often without anybody even noticing. But if you don't notice, it doesn't mean it isn't there, and then you can find yourself in a situation where you can't back out of it. I know it's a bit like what happened with like Microsoft and Windows. It's a bit like that. It's when you have if you create a broken architecture, but then create a bunch of software. I'm not saying that broken architecture there, or so much. Depends how you look at it. But if there is stuff that you build software on, and it's broken, and it becomes a standard, yeah. I mean, ultimately, it's quite fitting, really, just in the same way as the normals became 0, and so thus the object became black, kind of reminds me of the joke of how many Microsoft engineers does it take to replace a light bulb? And the answer is none. You just make the broken light bulb the new standard. That's the way that old joke goes. And then everyone's in the dark, aren't they? I don't know. I imagine that they will support Win32 up until it's more profitable for them to not support Win32, the normal form. Yeah, but simple APIs, you know, simple APIs are empowering. Empowerment is how profitable is empowerment? Just it's an innocent enough question. Right. So what was I doing before that great digression, or not so great, depending? Found it. I can. What's multiple values? Apparently, somehow I managed to select two things. So let's just move this. Eat that. Let's just move this thing. Right, great. And then I'm going to try and click on this. That's it. Now, let's try and move this and see. If I'm here and I go like that, that's 10 units. All this effort was to just understand how big this plane. I asked for a plane appeared. It looks pretty small, but how do I know? And in fact, I can see here, that's 10 units. I mean, maybe you can't because that window's very small, but I'm looking here. And maybe I'll do this. Oh, no. That's another thing I'm really annoyed about. These types of windows, it's like that you can't. They always stay above everything. I'm just going to close it. Bye bye. So, as I move this around, there I'm at 0, 0, and each one of these is 10 units, and this is 100 units. That is a meter. The plane is 1 meter by 1 meter in size. So again, calling it a plane is probably a slight exaggeration. Let's put it back in. Let's have some perspective. And then, can I rotate? No, I want to rotate the object. Oh dear. Okay, so this is proof that the light is working. Whatever works. Used to the controls are sort of subtly different, of course, between Unreal. Oh, and everything's gone. Between Unreal and Unity. Let's not standardize it. We'll have a few little differences. Like keep everybody on their toes. So as I change the angle of the light, it changes the amount of lighting. So that confirms we now have a light in the scene. Okay, great. Let's get a cube in the scene. Cube. This cube is lit on one side, it's light on one side and it's dark on the other side. You see that gizmo, the way that it flicks and changes its perspective according to how you are rotating the camera. It's kind of clever, but I find it really annoying because it's just distracting. It's like flick, 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 flick. Oh dear. Thing blinking around. So what I'm going to do is select that. Can I? I've selected it. All right, that's fine. Can I scale it? I want to scale it by, it's a plane, right, 1 meter. So in fact, because of the size of the mesh, this scale is in meters. That's confusing. But the units of Unreal are centimeters. So I want to make something that's 10 meters by 10 meters. So we have that. Then this light, and let's just save that. And I'm going to just save it as, say, 1. Is it a scene or a level or a map? It's, you know, it's called, sometimes I see it called any of those. But it saves it as a map file. Where's this light gone? Here. It really doesn't matter where the light is because it's a directional light, so I'm just going to put it out of the way. And that was what I was hoping for. Shadows. I mean, it was just entirely like try it and hope that shadows work. Shadow with a weird mark. Preview. Oh, the weird mark. That's funny. Because I'm going around, going, look at this, and I'm going, what is that? What is that defect in the shadow there? Oh dear. That's weird. Is there kind of a mark there? Then you zoom in on it to see that it says preview. Okay. Comforting. Yeah. So I now have a shadow. I'm going to save because the shadows are nice. I'm going to hit play and see what happens. That's very interesting. The preview shadow and play. So it still has the preview thing, but it's blurred. So it's actually less of a preview in editor than it is when you run or something. Odd. Okay, how do I... Lighting needs to be rebuilt. So to rebuild the lighting, how do you rebuild the lighting? I don't know. Details. Viewports. Layers. How do I rebuild the lighting? I remember doing this before, but I've forgotten. I guess we'll have to go on the semantic web. I'm just curious. The semantic web is an extension of the World Wide Web through standards set by the World Wide Web Consortium. The goal of the semantic web is to make internet data machine readable. It's important for it to be human readable, actually, but I mean, it's the thought we can have this whole internet thing and then machines generate the content and machines read the content.
Hello, Dino.
Yeah, hello. No, what I'm looking for is rebuild lighting Unreal. Hey, Tony Zag. Hi. So, can we call you Tony? Because normally we call you Zag. What is the hard thing? You guys keep on saying that. I don't know what that joke is. What is that? It must be a meme. One of those meme-y things. How do I fix the lighting needs to be rebuilt? Let me turn on the heater. We have the same problems. Try rebuilding lighting. Try rebuild lighting. Hit the drop down arrow next to build. The drop down arrow next to build a new thing. Oh, here. Yes, that was it. Oh, look at all these things. Wow, that's a lot of building stuff. You can just sort of build. Okay, but I don't want to build everything. Build lighting only. Control Shift semicolon. We're building the lights. We're building the lights. We built the lights. Still building the lights. The light building is completed. Light building 100%. And after that, there's been a... Okay, Zag. It's all right. We'll call you Zag. When it was 100%, it still had something more to do. Of course, it wasn't really 100%. Because I was sitting there wondering, why does it still say preview? Other questions on my mind are, why is the face of this cube a shade of green? Do you see that? So where'd that green come from? I do tend to ask awkward questions, I know. But it's like, what is that green? There is no green. Is green this side as well? There's a greenness. Kind of interesting. Why does that side actually get lit at all? And the reason is because it's the scattered light off the plane. So when you do this, you get full thing. That's why. Yeah, you know, that shadow looks really realistic. It's just so black. Technically, now you see, we're going to get fussy about realism in computer graphics. It was just bugging me. Something was bugging me about this, and it was like the uncanny valley thing. I was going, what's wrong? What's wrong is that this shadow is a black that is like completely black. It's as black as the background over here, but in reality it wouldn't be, because this surface here, which is being lit by the scattered light off the plane, itself is a light source and would light that shadow. So this shadow should not be actually completely black. But a bigger concern is where does that green come from? There is no green. And yet there it is. Unfortunately, if you're building a game with some kind of time pressure involved, you are going to just ignore that kind of stuff. And maybe there's an explanation. I mean, I noticed that there's a kind of a green-ish tinge when I look at this. It's glowing. You see that? It's a kind of glow effect around here. But the glow is green. But those types of things really bug me, and then now I have to make a choice. Do I investigate why this is green? do I get on with my main mission? Oh my. Oh, so it's a positive word then. Okay, that's cool. We need more positive words. There's a kind of definite lack of them. Why is this green? Anybody know? Could actually be saturation. Why particularly green? Not sure, but it could be that. I mean, we take this directional light and see light, and the intensity is 10 lux. It's always better than less lux. Very fussy on the slider there. So 1 lux. And now there's a clue as to why there was green, because I reduce. Wait a minute. Why is it so bright? Oh, it's not saying that I need to rebuild the lighting, is it? But I need to rebuild the lighting. So in fact, it doesn't always tell you that you need to. It doesn't, because I changed the intensity of the light. For some reason, it didn't detect that. Is that a bug? I'm going to just rebuild the lighting. I imagine then that the cube is showing the scattered light off the plane. There we go. Still, I'm here to learn. You can see lots of green. It still doesn't seem quite realistic, does it? Because there are a whole heap of things which are a little bit suspicious. On this side, the top is the same colour as the plane, and that is what you would expect from a directional light. But the sides are brighter, but they aren't facing the light as well. You know, because the light is fairly down. Or maybe not. Okay, that could be. The light is actually pointing a bit. Yeah, okay. And then these could actually be responding to the scattered light. But why then is this brighter than... So the underside of the cube is the brightest surface on the cube. That's just from all the scattered light. But maybe that's correct. The really weird one is that tinge of green there. So I suspect that the lighting has some peculiarities. There's certainly a green has come into it, even just across the plane, which might be the light colour, but you look at the light colour and the light colour is not green. Of course, now as I change the light colour, I have to rebuild the light to get the correct colour on this side, and it's not telling me that I need to rebuild the light. So if I make it red, we have a red looking plane, or blue, whatever colour I pick is being reflected off, scattered off the plane, because the plane is white. Well, that's an assumption. I'll need to check if the plane is actually white or not. RGB 111 white. That's interesting. 565. It does look a bit like that. You're thinking about some kind of bit compression, but let's try changing the light intensity down some more. 0.1. And Right, so only you can see that, but the directional light, the specular component is white. But the diffuse is definitely green. And even without, physically base lighting. I'm going to change this to 0.2. Need to investigate the plane. It's possible that it appeared white simply because of saturation. If you take a light and you make it bright enough, all the red, green, blue components just max out at the maximum values, and you end up with bright white, and you don't see the color. So there is a possibility that this material has green in it, I suppose. Oh, well. This is where the green came from. You weren't far off. It looks like 0.6. Well, it was actually, but the idea 0.61, 0.71. It's a shade of green. And so now I know where the green came from. If I double click on this, I should be able to set this to white. This is all good learning. The wrinkles of Unreal. Funny thing is I made that white. Ah, no, it looked blue. Oh, right. The red was not. That's white. I got it white. And now the colour is gone. Okay, so that's a relief. That problem has now resolved itself. I'm going to rebuild the lighting. If there's still green. Why is there still green? Probably because there's green on the material. Funny that the default, I'd make the default colour of materials white, not slightly green. But I suspect it's this cube. No, that's white. It's changed the material for everything. Why is this cube? No. Green. It's all gone green again. How did it revert? Oh, because I didn't save it. Okay, another lesson learned. Let's try and go back here. 1, 1. Okay. This is white. Close. Would you like to apply the changes of the modified material to the original material? Yes. I really would like that. Thank you. And probably might be because I didn't save it. So the plane is now not green. The cube remains green because I need to recalculate the lighting. Rebuild the lighting. Really want the green to go away. Tired of this green. 100%. Wait for it to update. See, hold me in suspense like that. Have to hang around and wait. I got rid of the green. Life is composed of small victories. That was a pretty tiny one. It's kind of interesting looking at this as well because the next query I've got, sorry, I know I'm a bit of an awkward customer, but it's like, why is the shadow rounded? The shadow shouldn't be rounded. Now it could be a... No, that looks very rounded. There's no doubt about it, really, is it? It's rounded. Why is it rounded? I wonder how much work it would take to find out the answer to that one. It's interesting that when the colour of the material is actually white instead of a shade of green, the shading looks a lot more realistic on that cube. It's much more believable now. So that's a little bit interesting. It suggests that the math involved in doing the lighting calculations has some little quirks. But the shadow, it's a cube. It doesn't have rounded corners, but the shadow is rounded. I'm going to try rotating this, and then of course when I rotate it, the shadow does not change, because that shadow then needs to be recalculated. I need to check what kind of object is this cube. It's a static mesh actor, so that's one issue. It's not meant to be moved. This is an object that if you move it, you need to recalculate the lighting. It actually doesn't say that I need to recalculate the lighting. Kind of handy to know if you need to recalculate the lighting reliably, because that can take a while, and you don't want to sort of do it necessarily. Hope that if it doesn't need to be done, it won't do it. Well, let's try and see, actually. Building lighting 100%. Okay, so having rotated the cube, still rounded, you can see there's a new shadow there. What I'm going to do is go to my cube and say, where is this? I still don't understand, is that I'm really interested in the transform, and then I can't find it. Where is the transform? There. I couldn't. Oh, I needed to scroll up. Maybe. Okay, that was why. Okay, it's a static object. It's a movable. Casting a dynamic shadow. It's the slowest rendering. Don't care. I'm going to switch it to movable and save and rebuild the lighting. So if it's movable, we should have a nice dynamic shadow, and that's what I want because I'm interested in movable objects. Now, it's interesting, but the dynamic shadow is more realistic than the other shadow, and that is probably not too surprising. Generally, for practical reasons, the shadowing, well, it's different. It uses a different algorithm. So you can see that it doesn't have rounded edges, but on the other hand, it has this noise. And there are probably settings, change that, quality settings to change the way that behaves. Also, being a dynamic object, when I rotate it now, we should see it responds to the light. So all right, that's cool. So I've got that, and I want to make this thing spin, I think, when I hit play. Actually, what happens when I hit play? At the moment, nothing. Okay, that's good. So I will take this now and move this here. Hit play. Well, that's nice. I'm really that makes it worthwhile to start from a blank scene, because the other scenes when I do this, then the camera immediately zips into a player controller, and it's like, look, I've got the camera here in the editor. It'd be nice if I could play and it not sort of jump the camera about. And so here you hit play and the camera is staying put, and that I like very. They've still got all this other crap appearing. It doesn't seem to be interfering. So, all right. The next thing is to look at the level blueprint. Need to see the. Can I take this output log and dock it? Oh, I can. That message log. The compiler results are. Anyway, we'll leave that as it is. So now I've got the level blueprint. Is it the map blueprint? And I want to do everything in here. I know very often when you look at tutorials for Unreal, do things like create a behavior and throw it onto a cube, but I don't really want to do it that way. That's a bit object orientated, and want to have everything in one place, especially when prototype. So what I'm going to do is make this cube spin. I want to make this cube spin from the level blueprint without having to attach any behavior onto the cube. And this is the way that the viewer is going to work. Try it. So I want to make this spin. I think the way to do that, I remember, right, well, actually, rotation, rotate. Rotate. Oh, it's not an object. What I'm talking about. I need to find the object. Oh, that's another one. Find. There's how do you find this scene? Well, what you can do, this for now, it's not very, drag that into here, right? So now, this is a reference to that cube. Okay. I also want to have something called every frame. Well, actually, I've got one already. That's the event tick. So let's use that. If I drag from here, I can look for the word rotate, rotation. Add actor world rotation. So every tick, we're going to rotate about an axis 1 degree per frame. I'm not using the delta seconds because I actually want to get a sense of the refresh rate when running in the editor. I think it's 60. So this would be 60 degrees per second. That should just make the thing spin. Let's see. That's quite pleasing. It's indeed spinning. It's quite calming, isn't it? Sphere. We have our spinning cube. Now, in order to work with phi, I need a few things. I want to be able to create the cube. So now I'm going to see if I can create a cube. Initial research into this. What was it? I like to do it from script as much as I can and avoid putting content. You know, it's the same thing with Unity. Sometimes you wonder if it would be easier if we just generated our scenes from a scripting code. In this case, I want to generate the scene from a blueprint, because ultimately I want to be able to generate the scene from phi. You know, I say phi can say make a cube, and the cube appears, and then phi says move the cube, and the cube moves. So it's entirely irrelevant for me to try and do everything within blueprints. Keep it dynamic. So I probably want to create, add actor to layer. What a layer is. Actor. They have various kinds of actor. There's get actors, remove actor from layer, set focus actor, cast to actor. Lots of casts. Incredible number of casts. So many casts. Hello, Hal. Hello, Hal. You've been very quiet, Hal. Hal has been very uncharacteristically quiet. Hello, Hal. Hello, Hal.
Hello, Dino.
I think Hal fell asleep. Get actor array, average location, destroy actor. Well, that's really nice. Let's just keep that one for later, shall we? Before I can destroy an actor, I need to have created the thing. Break link. Back to searching for actors. Oh, actor hashtag. Okay. So that one's a good one to remember. Actor. Get all actors at a class. Remove tick prerequisite actor. Add tick prerequisite. Get actor array average location. Set fire. Get actors. That was a yawn. Add child actor component. Creates a new component and assigns ownership to the actor that is. Yes, this is what I've been looking for. Where is it going to? I think what I'm also going to do then is look for an empty actor. So in Unreal, an actor is the name that they give to an object. Yeah, I can't do that. Do it this way. When you hear actor, think object. Okay, that's. I put an empty actor in the scene. I'm going to call it root, so that everything is a child of root, dynamic stuff that I generate here. I need to get a reference to that root. Then I can put that in here. So what I create here will be a child of root. This is handy if I need to move the dynamically generated content in the scene in some way. Now I can. I don't know if this will run. We'll see. It will be an error, won't it? Oh, it ran. I don't know what. Probably we might see it in. Well, we would see it easily here if it wasn't for all the other crap that appears. We would see it as the child of root, though. So maybe it was ignored because. I need to be able to tell it what. It says do not call manually. Blueprint internal use only. Yeah, but I want to just make a cube. Can't I do that? I don't think I can. Child actor component. There's no way of specifying. So, it's probably derived from it. Okay, so I think the only way I can achieve what I want to achieve is basically I take this. Yeah. I have to take this cube. Maybe I can drag it here. No, that's what you would do in Unity, and then you would have a prefab. I think in Unreal, static mesh actor, not anymore. Interesting. Drink. what I have to do is go to my cube, and go convert cube to static mesh. No. Blueprints. Convert selection to blueprint class. And you get this thing, and you say new subclass. I hate the fact that you end up with so much crap lying around. It's like, well, here it is, a cube blueprint. I think what I need to do is delete that. I can take this and drag it in here, and then you've got add child actor component, and it's going to add a cube. Now this is fine. Not make everything dynamic. All the different hardware I coded on. I suppose that could be interesting. Yeah. Maybe I should do a podcast of my life story. It's easier than writing a book. It's the funny thing. Writing is quite hard, but I can sit there and just sort of waffle on for an hour. Might be not bad. It might not be such a bad idea. I have to wait till I'm a bit older and I've got nothing to lose, and then I can talk about things and people. You know, my interviewer, I'll just ask me a question. If you want to do that, just ask a question and I'll talk about it while I do this. Add actor world road. Right, so what this means is that the things that I want the graphics terminal to do, whatever the components are that I can drive from Phi, they have to be in the project, and that kind of makes sense. There are probably more dynamic processes involved. I mean, I'm hoping I can do OpenGL like calls. The longer I leave it, the more it gets filtered to the important stuff. There's certain things I will never forget. Like, for example, the sandwich section of the school I used to teach at. They had a kitchen area. There was a time where there was a place where the staff ate and where the students could eat. And there used to be, and there still was when I was there, actual serving hatch, but they could serve both sides. But they stopped using those, so they were never open. So the teachers would have to go into the same area the students were going into. Which is fine. I mean, you know, there was this corner, in the corner there was a sign hanging from the ceiling. The sign said, "Fancy sandwiches." That's like, you can go there to get the good stuff, the good fancy sandwiches. Now I have to explain that, you know, being Italian, a fancy sandwich, that's got to be so good, because in Italy, well, the sandwich. It's true, they're not sandwiches, more like panini, but they do also do the sandwich. They call it tramezzini, I think. But in Italy, the idea of putting something in bread product sandwiched in there somehow, they're masters of that. I mean, it's just, it's my favourite thing when I go to Italy, frankly. Right there in the airport, you arrive at the airport, you talk about airport food, arrive at Pisa airport, and there you can get a genuine panini with either mozzarella, tomato if you want, all kinds of stuff, and of course Parma ham, crudo as they call it. It's not always Parma ham, but it's that thing. They call it crudo. Cotto is cooked ham, but I always like and salami, and you just walk in there and you can just take this thing, and it tastes. And even when they're not really great, they're still pretty good. But when they're really good, when they bit of olive oil, yeah, it's brilliant. So you can imagine that I'm going there and I see fancy sandwiches. They better be pretty fancy. What amazing sandwiches will there be on this table? Right as far away from the serving hatch as possible. Fancy sandwiches. You go over there and it was like, I remember looking at it, it was like, this is 2 pieces of bread with, egg mayonnaise. This is 2 pieces of bread with a slice of cheese. This is 2 pieces of bread with something that looks like salami. And they were the fancy sandwiches. And over the years, the fancy sandwiches sign actually remained well after the time when there were no more fancy sandwiches, because the fancy sandwich days did not last. And so for the last few years that I was there, probably the last couple of years I was there, or last year I was there, I would go in to find myself something to eat. And, I did tend to like to go to the fancy sandwich table in spite of that, because you can imagine if those are the fancy sandwiches, but the fancy sandwiches disappeared and they were replaced by sort of confectionery, like Mars bars and things like that were on the table, and there were no more sandwiches eventually, but the sign remained. I remember it like yesterday. Fancy sandwiches. So I had in mind to actually create some kind of thing called fancy sandwiches, recount certain my experiences, and you can bet that in my memoirs there will at the very least be a chapter entitled Fancy Sandwiches. So there you go. Do I remember people's names? Yeah, I can remember some. I forget some, but I do remember some people's names. Yes. If I remember somebody's name, they were either very good to me or they were not very good to me. With a picture of fancy sandwiches. I kind of missed that sign. It was a very important part of my life, as you can tell. I almost want to make a fancy sandwich sign and put it out there on the roof to remind me the importance of something. I'm not sure exactly what. Can't quite put it into words. It's like a Zen thing. Always beware the fancy sandwiches. It was a dark and stormy night. Anyway, right, look, so back into this. On event begin play, I create the actor, and I add it. So this should add the actor. What happens if I run this then? Blueprint error. Access none. Trying to read property of unknown. Warning. Lots unknown. Ah. Wait. Root. See. Actor for world rotation. Ah. Yes. Let's try this. It doesn't work. Oh, why not? Look, the return value of child actor component. Surely that needs to be the thing I rotate. Child actor component reference is not compatible with actor object reference. Get references. Did I go back? I never. When I left that place, I never returned. Karina carried on working there for quite some time. While we were sorting out her visa. I would love to know if the sign is still there. It would be kind of comforting if the sign, the fancy sandwiches sign, was still there. But what do I do? You can see that's pretty mild. You can see how it might be a good idea if I don't publish my memoirs until I'm too old to care that people complain. Oh dear. Because I can be a little bit sort of like be a naughty boy. Let's say mischievous. Yeah. Or let's say I'm tempted. But I rarely give in, I suppose. Or do I? I don't know. That's for other people to judge. What I need to know now is how to get this into there. That's the problem. I mean, can I rotate? Can I get this and put this in there? Oh, it's totally happy with that. And that will spin the world. There's nothing in the world. That didn't work as I expected either. So yeah, let's just forget that. Yeah, I don't know. I suppose I could hide the names. If you leave it long enough, if you leave it long enough, then there's no way that people can trace who you're talking about. And then you can talk about the things that have happened in your life. It's always a bit... Or the other way is to write a work of fiction that is inspired by one's life, but a lot of people do it that way, I think. So, or I can write a song. I mean, that is something I actually do. Sometimes people inspire me to write a song, and I write a song. And they're so vain, they probably think the song is about them, you know. I'm not getting very far with this. This is annoying. I create... Right. I'm going to go and remove this from the scene. Now if I hit play... What? Okay, at least I see it in here. There is a cube blueprint. Where... Why can't I see it? Show me the cube. Damn it. There's no cube. The cube is at 0, 0, 0. Oh, this is really annoying. On begin play, alright, let's try something else. Can I drag this into... Now, if I can't drag into here, how do I make an object a child of an object? Do I have to sort of drag it in here first and then do it like this? I suppose so. Hey, look. I've got 2 cubes. Can I move the camera to it? Movable mobility. One. This is frustrating. Like, what am I doing wrong? Because I have a ref... Oh. No. Add... This adds one of those. This adds one of those. That's what it does. It adds it to a parent, the parent being the root. Better check if the root has a 0 transform. It does. It is located under... Oh. I bet you it was there. It's just it puts it under the plane and then it doesn't get lit and then you just don't see it. That would be really embarrassing. Because the plane is 2 meters high. It's raised 2 meters. Okay, so now I have put the plane on the ground. Let's try. Oh, neck. That's it. Yes, it was. It was working. It really was. Now I want to make it appear above the plane. I can make a transform. Make transform. And then the location like 2 meters higher, which is 200 is 2 meters. Oh no, there we go, 200. So if I do this, I've made a transform that is an offset of 2 meters in the, vertically, and I'm going to position this object relative to its parent with that. So the cube should appear in the air. Nice. And having created the cube, I want to spin it. That's the thing. So I have to do convert this, and I can't convert child actor component to an actor. Maybe there's get actor. Actor. Get owner. Wow. Could it really be that? About to find out. Oh. Oh, that's not what I wanted. It's actually rotating the parent. I think that's rotating the root. It'd be really nice if I could edit this graph while the thing was running. I think I'd map some keys here for this actually. F5. No, I didn't. Let's go and just break input nodes. What? No. Break that. If I just rotate the root node. Yeah, it's exactly the same. So this get actor is getting the parent in effect, get owner. But I don't want to get owner, I want to get this. Child actor component. Let's use context sensitive thing, and we'll do a get and see what kind of get class, get object name, get outer object. Returns the outer object of an object. What is the outer object? Not interested. It's not that. Get component interval, get world position up vector, get attach parent, all socket names. Timer elapsed remaining, get physics volume, get blackboard asset. Parent components, get owner, get child component, get component bounds, get references, dependencies, get all asset, get cache paths, get primary asset ID. Get child actor class. Get component amazing. Get actor from child actor component. Actor reference from child actor component. Is it possible to get an actor object reference from a child actor component? Hey folks, I was asked 5 years ago. And they answered their own question. Because there was just a flood of people trying to help. Seemed like pretty fundamental. Yeah, it's a bit of a contortionist act currently. Hopefully they will correct that soon. If you're only picking through a very select few, you can also use tags to specify which of the child actors you want. One, child actor. Get child actor. Or maybe it's get child actor, which sounds a bit confusing, but... Oh, come on, get child actor. Ooh. Fence. Those balls. What did I see? Deprecated. Replicated. Read the value of variable child actor, the actor that we spawned and own. Oh, all right. I got there then. So that's fine. So now I'm blueprints, put the cube in the scene, and then I can rotate it. So these two things here are what give me the ability to spawn a component and then manipulate it. Now, thinking about where to go next with this. I want to get the... Can I wrap things up? I like wrapping things up a bit because I think I'll use some macros just to try and keep this manageable as it gets bigger. The transform, yeah, that can be an input node. The root. Can I convert this selection? Stop. Convert selection. Convert selection to a macro. Collapse to macro. Oh! That's pretty neat. I didn't know you could do that. So you can actually just collapse those nodes with a one. That's pretty sweet. You can do in place, convert to a macro. That I like. Now that I've converted it to a macro, I can pass in some other parameters. So for example, I want to set the transform. Let's do that. So it's actually going to take a transform. That will go straight to here. I can get rid of that. Root is a global. We convert this. We've got this output here. It looks like I don't need to put yeah, I do need to pass through the execution as well, so we'll make this an exec and move it up. I'll pull that out. We can connect that to that. So now back here, this now has an out. Let's name this macro something better. It's going to be called spawn cube. Spawn cube. Spawn cube. I switch back. This is now called spawn cube, and I can specify the offset. I'll get the child actor out and check this works. It does. The offset has changed, but I can just go and do make transform, pass that in, and start this off at 200 height and hit play, and now that's good. This is quite clean. The default, if I don't specify that, is for it to be just, you know, at the origin. This is the event tick, which was a nice little experiment, but I don't need it anymore. Let's delete that. Now a cube appears, and it's basically that. And I can specify where to make the cube appear. That's pretty good. Now what I'm going to do is try to hook this up to the socket. So we have socket listen, and we'll listen on port 7777. We listen on port 7777, and then we want to do a socket wait for a connection request, then socket accept, then socket wait string, change that. Socket. Did I have circuit weight strings? Oh, we'll see. I'll just do socket weight string and see how this is going to behave. We're going to take that and print something. It's going to print hello when, oh, I need to get the string. Socket and get string and get receive string. What's the difference? I don't remember what that was about. Socket weight. Socket get string. It's odd that I've got the other one. Must be listed in here somewhere. Twice delay, wait string, socket get receive string. Ah, yes. Okay, I'll need to just tidy that up. But what I need to actually do at this point is get the receive string. Just gets the one that was received from the wait string. Get receive string, print string. Save. So now this is using my code from the networking code, and we're going to go all the way to Sigwin, connect, type something. Every time a string comes through, it's printing hello right now because I didn't pass the thing through. So now when I connect, yes, that didn't work. Why not? Probably because it was. That's weird. Why would that change? What happened there? Break the link and try again because it did. Oh, I know exactly what is wrong. We need the event end play. When we stop playing, I need to use socket. Shut down. Try that. Hey. Okay, it might be that I need to stop it once. We'll see. Problem is that it might be that under the hood it's still running these things. Yeah, look, I'm not playing and it's still connecting to something. It's because I forgot to tidy up the socket. This is not recoverable without restarting. HAL initiate Unreal restart protocol.
That's a mouthful. You should have used boost.
Autos work. Let's open up the level blueprint. Did I forget to save? Might have done. That's really annoying. That script. No, but that's the script should have. If it doesn't save. Hang on a minute. Nugget test. Okay. This other scene. Scene 1. Yeah, there's the scene. Let's open the level blueprint. There we go. It's all good. It's all there. Let's hit play. Go. This. Connect. When I stop playing, then I hit play again. Let's make sure that restart is working. Yeah, okay, so let's fix that. If I connect the string up. Alright, that's all working. So what we then do when the string is received, we got there, we do the socket listen, wait for the connection request. Yeah. Well, I mean, to be fair, you can choose which bits of boost you use. The problem is that if you're a real programmer, you use all the boost all of the time. Get the receive string. So this provides me with strings that come over the network. When a string comes over the network, we shall spawn a cube. So this is the first example of making a cube appear from over the network. That is quite pleasing. Of course, whatever I say, it creates a cube right now. So that's not exactly useful yet. But it's de-risked, right? I'm able to trigger the creation of a cube from the network. Now I need to think about how to parse these files that are coming in, these strings that are coming in. So I could, of course, do this in C++, but where's the fun in that? Part of what I'm looking at here is how to make complex blueprints and keep them manageable. How to avoid blueprints from hell, which are just a pictorial version of bad programming. So a socket get receive string, I need to break this string down. This is going to get interesting because I need to have a way of parsing a string. Parse string in Unreal Blueprints. This has got to be a very popular YouTube channel because it has WTF. Very fashionable. So now I've got a page. At least I asked for parse string in Unreal Blueprint, and I got a whole page of WTFs. I can't be bothered with that. I'm going to actually just try and see what can I do. Can I just, the return value is a string. What can I do to a string? Parse it into an array. Oh, look at that. That's pretty cool. But that has that. All right. The delimiter is going to be space, the final frontier. These are the voyages, Starship. Right, and now I've got an array, and can I get the? Can I do a switch? Oh. You can only have edgy language. I don't know. Maybe. What I want to do is switch the spawn cube goes up there. I need to do a switch, so I've not tried a switch. There must be an equivalent of a switch. Switch on string. I'll go with that. And the return value from here, we have to go to a get. Given an array and an index. Yes. We can do this. So I'm getting the first word of what I type. This is now getting quite rapid. And not so messy. So parse into an array, get the first word is the command, and so then I can put the cases in. How do I specify the name? If I'm to switch, as the default, add pin, case 0. Okay, but how do I... That's pretty useless unless I can specify what the case is. Oh, maybe it's a detail thing. Edit, duplicate, refresh, find references, toggle add breakpoint. What is the add execution pin? What the hell? Pin names. Expand that. Oh dear, oh dear, oh dear. Wasn't appearing. Okay, so what I'm going to do is... be the command cube. So if the command that comes in is cube, it will spawn a cube. Otherwise, it'll just print out something that says, oh no, command. And I'll save that and play. And now I've got a blank scene. And I go here. And I go like that. Make my connection. And I type in some nonsense. And it goes, unknown, no, unknown. Typo, command. Or I can say cube. Cube appears. It is starting to come alive really fast. I'm enjoying this. This is fun. It has now entered the realm of fun. Unknown command, right. So it spawns the actor, spawns the cube. I want to be able to... Jeez, this is going so fast now. God, I'll be able to whip this... Well, at least for manipulating cubes. You know, just wait until I want to put text on the screen. That will take a whole day, probably. I mean, but... So I have to figure it out. But that is cool. So what I want to do then is I want to say where the cube is supposed to appear. So maybe the command will be I'm just designing the command. Something that would be not too difficult to parse. I can say I want a cube, but I want to specify well, I could iterate through the commands. I think I'll try that. So when spawning the cube, before I spawn the cube, I should parse the rest of the command arguments. So this will go from here. When it says cube, we do a... Oh, but how can I avoid duplication? Oh, all right. I think you know what I'm going to do? I'm going to just, do something slightly different. This command is going to be make. So I would say make cube, but it would be a series of properties. So this make, I want to know what I'm making. So I do another switch on string. Get, this will be argument 1. So if there's a make, argument 1 is this switch which says make. A second argument, add a pin. This is going to be called cube. And actually this one, yeah. So we do a make cube. This will actually make the cube. But we don't want to do that yet. So in actual fact, I need to take that and store it in a variable. It'll become clear why in it. So yeah, I'll have to delay that. What I am making is in here. I'm going to create a variable which is going to be making. And we'll do a set making like so. Why is it? Oh, because the type of making is string. Yes, change the variable type. And there it goes. So we're set making. But that is done here. This is the variable for what we're making. And having actually... but I need a counter as well. Count. And... go. The count needs to be set to 0. Set count. Count is set. Count should not be a string. Count should be an integer. And it sets the count to 0. So there we go. We set the count to 0. Then it should, we're going to set up a loop. This get is this count, in fact. Now, let's set it to 0. We get the 0. First word in the line, separated by spaces. Then it stores, if that thing was make, it stores it in a variable called making, And then after this has to go back. But it needs to go back somewhere, incrementing the variable. Right, so increment an integer, and the integer is going to be get. I have to get the integer. It's incrementing count, and having incremented the count, we go here. See that we have a loop. So it starts getting messy again pretty quickly. Oh man. There we go. And yes. And actually, this isn't quite correct, because here we have to get first element. Then this one here should be the count plus 1. So actually, this graph is going to get even more messy, because I need to take my... Oh. Yes. Right. I think I need to add integer plus integer. This is the one that's used there. So whatever that counter is, one more is this second one that I get. And then this goes this actually needs to be I need to add 2. I don't know, maybe there's a better way, but I'm going to do 2 adds. So set the count to 0, we get the 0th element. We get the first element. The 0th element does a switch, and it does, if I'm saying make as the first word, then it's going to set making to the second word, because this is going to be the word after make, right? And it's going to increment the thing twice to get onto the next keyword. It comes back. It's going to switch on the new value of the count timer to get the next keyword. It's going to carry on like that until eventually it until eventually it exceeds the bounds of the array. Oh dear me. All right, well then we should probably do a little check here, which is I'm going to put a branch in here. I think we go from here to a branch. There we go. And that goes into there, and that goes into there, and this goes into the bin. The condition is that count needs to be integer less than integer. If it's true, it continues looping. If it's false, it exits. The less than comes from, yes, it needs to be less than the size of the array, for which I need to get this and convert it to, it won't do it directly, I have to get the length. So that's a huge button there. It's like, really. I mean, I've got a whole thing here with a complex thing that waits for a string from a socket, and that's smaller than get the length of an array. Anyway, there it is, length. Very important. Hey, Isaac. How are you doing? Do I know you? You need to check the length of the array before you go. Yes, exactly. That's what I'm doing. So I think it's a mess. That's the thing here, though. This is going to introduce an interesting thing, which is how to refactor code of this form. I did quite a good job with this bit, but this, there might be a way of doing a loop without all of this mess. There's probably a functional loop. I will look for that later. But when I was just thinking, what do we do when we finish processing the arguments we get here? And at this point, I need to switch on my variable. So I'm going to switch on a string, and the string comes from that thing that I set over here. So what we have are two switches. There's a switch for parsing the arguments, and then now we've got a switch for an actual command, which is taken as the first, well, not the first, but anything that I say make. So I say make cube, it'll run the code for making a cube or make something else. But I've also got the ability to cache any of the arguments which are sent on the line. And from there, we need to add some of these things. So we're going to add a cube. That was it. It's taken from the cached making. So I say make cube, and it should come here when I'm making a cube. And then somewhere in here I had the thing to make the cube and I've lost it. I must have deleted it. So, but that's my macro. So that was, what did I call it? Spawn cube. That was it. Spawn cube. And I'll just test that for now, because that was a lot of work without testing. I don't, I think it's good to test frequently, but this should be testable. It's not complete, but what should happen is that, well, first of all, there should be no compilation errors. Failed to compile something. Error here. Oh yeah, because I need to do that as well. Have reference to the thing it was incrementing. Save. I hit play, and right, that's compiling now. If I jump to my terminal here, and I just type in some rubbish, it says unknown command. Type in some more rubbish. It says unknown command. That's great. I say make cube, and it said unknown command. Oh, that's unfortunate. Make cube. Wasn't because it prints it out with an uppercase, even though the actual thing is a lowercase. Now we have to debug that. What fun. I'm going to can actually use the debugger for this. Probably the easiest way. I'm going to set a breakpoint here when we receive the socket string on the socket. We can do that while it's running. So I'll go over here and I'll type make cube. Excellent. And then we follow the path. So from here, F10 please. Thank you. It set the counter to 0. It switched on the string. Yeah, so it did actually match it. So it's a problem later on. It set making variable to make. No, to the next parameter, which would be cube. We can verify that if I hover over this, hopefully. Current value cube, which is great. Then it increments this count twice. Then it checks to the condition, which is set for a count currently how can it possibly be 1? The counter was incremented twice, therefore it should be 2. So now I think I've got a peculiarity of the blueprint system. What I'm going to do is rerun this test. So let's go back to here. Make cube. We can go so, like so, like so. Check the count. Count is 0. We execute an increment. What's the value? Value is now 1. Okay. Then we go again. And the value is now 1. Does not compute. Literally, it does not compute. That is very odd. How can the value be 1? I incremented it twice. So this is interesting because it suggests something about the way variables are handled in blueprints. I'm going to investigate that later. That's quite interesting. I've got some theories as to why that reminds me of one of the aspects of the Phi programming language, funnily enough. It could be that it increments the original value but doesn't chain it. So the way it handles these things internally, handles variables internally. So what I'm going to do is stop, and that would explain why it got the problem. Is it only moved on by 1, and then it, instead of reaching the end of the list, it tries to parse cube, and cube doesn't exist here, and then boom. So I need to increment my count twice. Maybe there is an add to an integer rather than integer plus integer. Adds item to set. Add item to array. It's a pity that it doesn't have a component where you could make one. Instead of being able to do it with just like add to this variable, then I have to do the following ugly thing, which is set count add to I can add 2, but I have to do it into the set. So basically it's a lot more messy because I've got to add like another node in there. There may be a better way of doing it because I'm new to Unreal, so I'm learning Unreal in sort of on this stream. So I was hoping that it would be just like an equivalent of increment, because in C++ and C you can do C plus equal to, or I could do count plus equal to, so that I can add 2 to count without having to say count twice. It's quite nice. But this you have to say count twice. Maybe, but I used the output of the first increment and fed the output of the first increment into the second increment. So that should probably have worked, because you'd think that the output of the first increment would be the thing incremented. It could also be a bug. I don't know. Anyway, so I add 2 to the count and have to set it. So, move this. There might be a better way of, actually I think what I'll do is just put this here. You see this kind of zigzag in other people's blueprints, trying to keep this under control. This This has to go back to here. That's it. Okay, that's probably about as neat as I can make it. And leaving aside it's crossing there. So I'm going to do that, but rather than just run it, I just want to actually run it with the debugger. So I didn't save it. Save. There we go. Make cube. Make cube. Network to make the cube. Ah, right, yes. Single stepping. Right, so I'm going to go hit F10, set the count to 0, and then the first word I typed was make. That matched. It sets the variable making to cube. It then goes through this process of adding to count. The count should now be value 2. It is. And the array length is also 2, so this should be false. So it goes to here and it checks what was it I'm making. Cube. It spawns the cube. This goes of course into it's gone a step, so it went into the macro, so that creates the add. It does the add child actor component, and there's our cube. So without the debugger, so this is actually, I mean, you've still got a problem with mess, but at least you can. The secret, I think, is to just do the same thing as the same secret as with proper programming or programming with text files. You need to put things into functions or into macros. Then what you've got is you might have a mess, but the mess is inside the box. So it really follows what I was saying, is that using blueprints is in fact programming. It's just programming with less typing, but it's absolutely programming. And so you need to be good to keep it manageable. You need to be good at programming, and you need to have the same skills of a programmer. It's like there's no two ways about it. Otherwise, you will get the same kind of thing that happens when an inexperienced programmer tries to program a big architecture. You end up with a mess that cannot be maintained. Same thing with blueprints. How do I debug it? Yeah, all I did was go on here and then hit F9, and so this, just to explain that, hit F9, he puts a breakpoint on here. Now, this type of debugging, with a debugger, this is very similar to what you do in Visual Studio with code. It's exactly the same, actually. It's not similar. It's exactly the same, except it's visual. So even for debugging skills, you need to have the debugging skills of a programmer. This particular problem I was working on here is totally suited for this kind of debugging, because you single step through the code. So if I hit play here, it's running, but when execution reaches this node, it's going to stop and put an arrow up on there. So I'll come onto here. I'm just going to do my thing, and I do make cube. Because the skill of programming isn't typing, so that's all Blueprints gives you, is no typing. It also gives you, I think, to be fair, it also gives you a kind of simplified API that has less noise in it. that can actually, and you don't need to recompile every time. So in that way, you can make things work a lot faster. That's why I'm interested in it for prototyping. But
Hello, Dino.
yeah, hello. But ultimately, you know, you put a you put blueprints into the hands of a non-programmer. It's like having a programmer who knows how to type but doesn't actually know programming. And so what we do when you get here is if you hit F10, it does a single step. And, you know, so then because this is a very one-off and linear action that is going on here, you know, you type your command, it's got a sequence it's going to do. The sequence is not time-based. It's like every step is understandable and you know how to, you know, from beginning to end, and there is an end. And so when you've got code like that, debugger's great. Where the debugger doesn't work is when you're trying to figure out problems that happen asynchronously over time. For example, you're trying to figure out how you know, a bug occurs when two objects collide in a very specific way, you know, or when you have race condition. You know, that's kind of what I was doing. Any kind of race condition is really difficult to debug with a debugger because you need to collect information on how things change over time, and you can't sit there sort of like, if you have to sit there and print continue on a breakpoint 50 times, it's going to take you forever. So the best way to solve those is by logging, you know. So does it drill down? If you, well, it did here. It's like at this point when I say spawn cube, right, if I double click on that, it takes me to that macro. If I hit F10 from here, it takes me in fact, because it's a macro. So normally you have a step to the next instruction. You can have a step into, which is usually F11. In fact, you can see here there's a step into. Why don't we try that, since you're asking? I've never tried to do a step into. I don't use debuggers usually that often, for the reason that if the code is linear and easy to debug in a debugger, it's probably going to be okay. It's like I'll be able to figure it out without really using the debugger. When I can't figure it out that I need to use a debugger, then it usually means that the debugger is not actually going to help me. There are exceptions. Generally, the debugger's biggest use is just to figure out where it crashed, which isn't relevant in C# because it will tell you. In C++, that's a whole nother ball game. So let me try running that again. And then down here, do make cube. So it's like, this is my function that I made. So I don't know what will happen if I do a step into. It's F11 or this. So it doesn't allow me to step into it because that's C++ code. That's this stuff here. So then you would want to have a breakpoint in Visual Studio, but I still haven't figured out how to make that work. I don't think I can step into that either. That's an internal function. That's internal. These are all internal. So there's nothing to step into except the macro. I think that's a fairly common pattern. Yeah, that's also true. You can use logs for that as well. And so I tend to just use logs. generally. It's also the fact that, you know, even for the disadvantage to using logs is that you have to recompile, and sometimes you can also make spam, and you can slow things down, and you know, if you have a race condition and the print statement slows down the execution and makes the bug go away, you know, those are the kinds of nightmare scenarios that you learn how to handle those situations too. But logs, that was how I debugged from the beginning. For the first things I wrote didn't have a debugger. I was writing in assembler without a debugger. When I the most important thing to have is a back channel. When I got an EEPROM emulator, I still got it. I used an EEPROM emulator on a Sega Mega Drive, and when I bought it, and it was expensive. It was something like 2,000. It was really expensive. It was something like £2,000, and we're talking about, you know, how many years ago? 25 years ago? Was it 35 years ago? Mid-90s. That'll be about 25 years ago. Yeah. Something like £2,000. But that was my development environment, that and a Sega Mega Drive. But before I bought it, I made damn sure that it had back channel, which it did. So you plug it into your PC, you could emulate an EEPROM, and you would restart your. So I put the code into the emulator, then restart the Mega Drive, and it would execute the code in the emulator. It would be in RAM. It had RAM in it. You program the RAM, but what it also had through the connection, I can't remember what the connection was. If it was a parallel port, probably. Remember them? It was able to. I could send, probably using a specific address in the EEPROM. Must have worked that way. I could write code to communicate with it that would send text back up to the PC. So on the terminal, you know, in a command window, I would have this live display of text, and that was the debugger. There was no other debugger. So it isn't a lie to say that, in fact, I'm just remembering. No, it's true. Kickoff 2, Player Manager, Goal on the Mega Drive, but also even on the Amiga and the ST, were all written pretty much without a debugger. I do actually remember there was a debugger on the ST. And I do remember sometimes using it, especially to figure out crashes. So it's unfair to say I never used it, but it was very rare. And I certainly didn't have a debugger on the Amiga, and I didn't have a debugger on the Sega Mega Drive. Yeah. That would be an interesting project, because I still have the thing, to figure out how to use it again, because I don't have the software for it. You know, debugging Player Manager was fun, with its 1,000 players, being bought and sold, full, you know, RPG-like simulation with NPCs that grew over time and aged and developed their attributes, and those fed into the live action football game that was based around Kickoff, or was Kickoff actually, just modified for it. So figuring out how the AI of the managers bought and sold players, and in response to the performance as they played matches, picking the players for the matches, dealing with injuries, dealing with substitutions, putting players on the transfer market, looking through the transfer market to find players to buy. There was AI for doing all of that. In the game, when you traded with an AI player, you could haggle with them. So I designed a whole little haggling, very small mini game of haggling. When an AI manager traded with another AI manager, they also haggled. So the philosophy behind that was that I made a simulation and balanced it, but the elements in there that were all going for real were the ones that also the same for you. And I developed the AI first, and then I introduced the player. And this was it was more or less also what I did with Kickoff. So I balanced the game. That's how I balanced the gameplay, because balancing the gameplay on something like Player Manager is like really challenging, right? Because there were so many, a huge number of variables. How do you balance it? So that's the way I balanced it. Make the living simulation first, balance it, then provide the interface for the player. And so that worked. They actually managed to balance the whole damn thing. I balanced it all by myself, with some help from playtesting from Steve Screech. But basically, I would sit there and run the simulation. And how would I follow the simulation? Because the problem is, it took a long time to run through like 30 years of seasons. So I had this dot matrix printer. and it wasn't a fast dot matrix printer. It was a cheap dot matrix printer. I think it was called the GP80, if I remember rightly. It was a weird thing. It had a drum behind the paper, which was with teeth that ran all the way across horizontally, and on the front there was the hammer that hit a piece of like typewriter ribbon. There was one hammer, one head, and basically the drum behind was spinning and it was going like this. So it wasn't very fast, but it was cheap. It was one hammer that basically did every single dot. And anyway, that was connected to my Atari ST, because I didn't have a PC. So the Atari ST ran the simulation and produced log files that were huge. They were bigger than I had memory for. I couldn't really, I suppose. Now I remember there was no memory, because I was using all the memory on the computer for running the simulation. Because of course, when it was running on the Atari ST, I threw out the operating system, because otherwise there wouldn't be enough memory for it. So this was standard back then. It's like, here's your nice Atari ST. First thing you do is get rid of the operating system. So that means that everything hit the hardware. And so what means do I have? I mean, I couldn't just sort of like stick it on a thumb drive. So literally printed it out to the GP80 and produced printouts this big. And I'd let them run on that like overnight or over a day, whatever. It would just be there. And then, I'll go do something else. And then when I had the results in, I would go through with a pen and I would look at them and say, okay, so this manager decided to sell this player that had these attributes and sold it, and its value was this, and was traded, and that looks like that made sense. Then I'll look at the next one and say, yeah, that looks plausible. And then I'll find one and say, hang on, I don't understand why this manager, who at the moment is, why is he getting rid of his best player? And it's like, why is he doing that? and then I could investigate it. But those were the days. They yeah, and it was this assembly program. Some people say assembly programming is difficult. It isn't. It's just different. I did a thing once to make a point. Somebody showed to show how Model ST. I had like a 520 and a 1040 later, but I started with the 520. And I also had one of those sort of square ones. And later I got a hard disk drive. I've lost those. They got, yeah, that's a sad story about how I lost all of the hardware that I had, all the retro hardware. You make mistakes. But anyway. But yeah, so I was doing this. What was it? Yeah. So somebody was making a point about how writing in C is more difficult than writing in assembler, and it was some kind of loop thing that was going on, and not very complicated function. It was just an example, and they said, "Look, do you see how much easier it is when you're not writing in assembler?" And then what I did is I went through and I counted all the features of the language that you have to think about, the meaning within the piece of C code. So you'd have an open brace means something, and I counted them. So that was one. But here's another 2, 3 feature. It's like, okay, then you have an expression, that you have the increment, you have the if statement, you have the else statement, you have that thing. I added it up, and I remember it came up to something around 50 things that you have to think about if you want to fully understand this piece of code. And I then went and did the same with the assembler version, and it came out the same, or actually a little bit less. Like there was a little fewer things to think about. So yeah, it's different, but I think, and it's certainly harder to pick up, but the whole thing about it being difficult is a little bit overstated. I think the reason why assembler is not a good idea is really almost entirely down to compatibility. That's what I think. Because I would use macro assembler. This was very important, though. I didn't just use an assembler with no macro facility. I wouldn't have been able to do it if that. Just like these macros. In fact, this is a macro here. So the assembler I used, which was the one that came with the Aztec C compiler, was a C compiler that had with it, of course, an assembler, and I used that. And it was a macro assembler. So you could take a series of instructions and sort of make a kind of template from them. Then that template you could pass arguments in, so you could have different variations of this macro. And I used that tremendously. But the point is that allows you to structure your code, so you can end up in assembler having extremely clean code if you really want to. You can absolutely do it. So there you are. And it was possible for me to port the ST version to the Amiga version, and also to the Sega Mega Drive when I did Goal. These things ported over very well, because I had a good separation between the hardware, the visual graphical implementation, and the actual game logic. So in some ways the architecture was the architecture was completely unhindered by the fact it was in assembler. And I did it, when you think about what I did in the time frame, and really you know, it's like, compare it to now, it feels like I'm slower than I was then, but in actual fact it's probably more like there are more distractions, like streaming. I don't know. Yeah, yeah, that's true. You don't cycle count anymore on the modern things, but it's one of those big mysteries I've been trying to figure out for years and years and years. Why is it that with all of this fancy technology that we have, things don't actually get faster? It feels like it's almost the other way. Teams should be able to just whip stuff out now. You know, I used to have to wait for the compiler, for the assembler to assemble the code on a 8 megahertz 68,000 with, you know, 1 meg of RAM, 1 megabyte of RAM, not 1 gigabyte, 1 megabyte of RAM. Waiting for the thing to compile was a big deal. There were various things that I would do to try and speed that up. So now, in theory, if I was doing the same thing with the hardware that we have now, I should be able to just sort of like, in a blink, it would just compile the whole thing and run. You know, we should be going so much faster, but we're not. And it's not because we're making more complicated games, because even simple games now, they seem to take an age. It's really weird. Anyway. Enough of that. I'll come back to what I was doing. So, I've managed to make a cube appear. So, just sort of previously, it feels like I go here and do make cube. Right, I still have my breakpoint, so I'm hitting F9 to sort of turn that off, and then I can just do resume, and my cube has appeared. So what I want to do now is add in how many gigabytes of RAM to run a compiler with the diagram tool. If you do it now, you will need probably RAM. You probably need at least 16 gigabytes of RAM. Want to know the funny thing? It could have been done 25 years ago. I know. I can't remember how much RAM I think I put 64 in this. This is a bit of a mean machine that I'm on here. Yeah, how much RAM have I got? Oh, I know a way to find that out. We can just go here. I'll just type top. Oh my god! What is this beast? 28 cores! Yeah, I splurged. But you know, I always do that. When I get a new PC, I tend to get, you know, the top end one, and then I use it like for years and years and years and years. 28 cores, but it's really 28 logical cores, so it's 14 actual cores. That's quite nice to watch that going. And then memory. Let's have a look. Yeah, currently using, so this gives you an idea, it's currently using 19 gigabytes out of 63. So yes, I've got 64 gigs of RAM in this thing. which, believe it or not, is in one RAM strip. I couldn't believe it. When I was trying to put a card in the thing, I looked at it and it was like, that's one RAM stick. It's 64 gig on a single stick. It's like, gosh. So then I was thinking, there's. It wasn't actually that bad. It doesn't have a really particularly good graphic card because I got it for the audio, but now I'm using it for everything. How are you doing, Tropical? Yeah. But it's got like three other slots. So, if it can put 64 in one, I could get this up to 256 gig. Which should be more than enough for anybody. It wasn't bad. I got it from what they called NXS or something. It's there it is. EXS, I think. And highly recommend it. Recommend them because there was seriously no nonsense. I ordered the thing, and it's a 19-inch. It's a 19-inch rack because I've got a small 19-inch rack for the music stuff, and put it in there. And really came, in a very timely way, and it worked. And it was all set up without all that crap sort of bloatware on there. It specifically was designed for audio applications. That's why it doesn't have a particularly good graphic card, but it's got a lot of cores. And I am touching wood right now. I've had no technical problems with it at all. Nothing. It's just worked. I didn't. Yeah, so I did not build it. I did not build it myself. So, if one is feeling like adventurous, you can do this. This just feels so wrong. Yes. Into /dev/null. I find it interesting how that is actually not all going on one core. Second one. It's streaming just Y return into /dev/null. It's 3. Five, 6, 7, 8. Oh no! I can hear the fan is beginning to kick in now. I thought for a moment it crashed. That's a lot of red going on there. You are lost. Well, every one of these, yes, /dev/null is basically a process going, that's throttled pretty much by, I guess it'll be the motherboard. I don't know, bus. or you just run one and it can only run on one core. So I've got 16 running now. So basically it's 16 totally pointless loops. $17, $18, $19, $20. Maybe I shouldn't push it. And now I have to kill them all. That's going to be fun. Kill percent. Actually, kill all. Have I got that command? No, I don't have that command. It'd be interesting to see if they all stop when I exit Sigwin. It did. I'm glad. I'm glad that. Otherwise, I'd be sitting there figuring. I don't at the moment. I always used to have it, but I install it from time to time and try to use it again, and it doesn't stick. There isn't enough of a reason, and it often doesn't work so well these days. One reason is would be useful is running Emacs graphically on my Ubuntu, but from my PC. Anyway, let's just stop that. The top didn't always used to be that impressive, but that's a really nice version of it in recent times. Anyway, look, all these distractions. I'll get back to business. So I'll make the connection. I type in something. It says unknown command. I type make cube. It makes the cube. So what I want to do is also add some other commands, though those commands will need to be put. I can put that here. I can add some more pins, not for make. Yes, make. Sorry. One is going to be position. Would be a good one. So I'm going to use the command pos. So let's implement that. Pos is going to go to set position. But I have to make the variable first. Oh, that's so irritating. I have to make the variable first before I can. Position. Set. Position. So that's what this one's going to do, is set the position to variable. I have to get this one again. Why is it converting from... Oh! What? Ah, yeah. I need to make sure that this is a string. Change variable type. I always forget to set the right type. It doesn't like that. It doesn't refactor out the cast when you do that. So, okay. All right. So this is... For these setters here, I'll put like that. So there we are. So this will set the position, which is also a string, and I think I want to get at least the position to work, and then it's getting late. I have to. So yeah, but it'll be good to set the position. So that shouldn't take me too long. But I need to have a syntax for that. So the syntax is going to be 3 numbers separated by commas. So this position is set. I need to use the position when I spawn the cube. And this is on a make. I'm also going to want to move things. So, okay, I can duplicate the code if necessary or put it in a macro. But what I need to do here is take that position. So if I go here and I go position, get position, I need to create a transform from it. So no, can't do that. I can drag this backwards. So here we want to make transform, and that will on the transform you set the location. So I need to get this to this, but no cast exists because that's converting a string to a vector. So I need to parse this into a vector, and I can actually probably get close to that by using whatever that was, split on array. I've forgotten the function, it's over here. Parse into array. The delimiter this time is going to be a comma. Return value is going to be something that I can take to make a vector 3. No. Can I turn... Ooh. Can I go from here to here? No, it won't do that conversion. Alright, I need to come back from here to make vector. Okay. And here we need to do get 0. And there's even a and right, that will get us, that's a conversion of a string to a float. Right, and then I've got to repeat this. Repeat this twice. Look at this mess. Prototyping, that's pretty good. And then what you could always do is refactor into C++. So it's actually really, really good. You try it out like this first, and then if there's a need, you can refactor it into C++. And do it gradually, not all. You want to be able to refactor a little bit at a time as you go. So important. Importance of that is so underestimated as well, often. Just generally in the industry. So you've got get 0, get 1, get 2 from here on there gives me 3 floats, which I turn into a vector, which I put into a transform. I put into this to make a transform. I pass the transform into the spawn cube function, so now I can spawn the cube anywhere. Well, we'll see. I'll try. Go. And oh, you disappeared. Come on, drag you over here. And make the connection, and let's see what happens. If I say make cube, I get a cube, but I can make another one. I could probably say make cube. Let's see, we try pos 0, 0, 100. So this is saying put a cube 1 meter higher than that cube. The moment of truth. Oh, that's sad. It didn't work. It did not work. You were here yesterday, weren't you? Yeah, some things have, despite lots of ranting and lots of talking about stuff, that we have an increasing velocity. It just, that didn't work. The cube was built. It's time for more debugging. Actually, this is quite hard because the debugger only works around these white execution links. It won't help you debug this necessarily. It might. No, because you can hover over and get the values. And there was an error. Attempted to access into. Alright, accessing an array. Delimiter copy. Cull empty strings. Stop. I don't want to. I don't want to cull empty strings. I said the delimiter should be a comma. Okay, I'm going to have to do some debugging. We're going to set a breakpoint here. Hit play. Yeah, it that just happened a few rants ago. So on here, I'm going to. You should do make cube pause like so, right? You know, DevOps always important. Echo piped into NC like so. So now I've got a one-line command that sends this. Maybe I already executed it, so let's just hit play and try that again. Did the breakpoint fire? That's weird. What? Oh. Something is. Everything was going really well, and now we have a little an issue of some kind. I'm scrolled to the bottom. I'm just checking all the usual. Oh, unknown command. It sort of woke up. It didn't seem to be responding before. Okay, so. Oh, right. Okay. Maybe my idea of that little script, the problem is it ends the connection, doesn't it? Yeah, okay. I can't do quite like that. I need to think about that a little more. So let's go back to trying to be too clever there. All right. Yeah, but that didn't seem to do anything. So we have unknown command. We can say make cube. Make cube. Okay, that worked. When I said make cube, it hit the breakpoint, but I want to try hit that, play, make cube, pause, 1, 2, 3. And that didn't work. So there's actually something else going on. I'm going to set a breakpoint here and try running that again. Not implemented. What? Make cube pause 1, 2, 3. Warning, hit breakpoint. Okay, I think what we have here is something's Unreal is misbehaving itself. It keeps saying not implemented. Okay, I can only assume I have to restart Unreal. I'll initiate Unreal restart protocol.
That's a mouthful. You should have used boost.
Hey, this time the automatic startup of Visual Studio worked. Doesn't usually. I've restarted. I need to open up the blueprint, the level blueprint, and go to this breakpoint, and I hit play, and I come back here, and I make the connection, and I type in something. Oh, it was because it was covering the arrow. That is so lame. I don't know what this not implemented means, but whatever. Oh, that's embarrassing. Okay, resume. Right, so in here we try make, I can copy and paste, make cube, pos 1, 2, 3. Right, let's proceed then. So we're going to set a count to 0. We're going to switch on the string. It was a make. We go and put that in making. We increment the counter by 2. We did not reach the end. The second one is pos. It sets the variable position. Oh, and then where does it go? Duh. It's like, no what? I didn't. It doesn't go anywhere. It just sort of says, okay, we're done. And it just exits everything. I'm going to have a bunch of these that all need to go to the same node. So I'm going to try. Where does everything have to? Everything has to go to here. Maybe I can double click on this. And then do that. Oh, look at that. So I can chain them together like that. That's fancy. All of this just to print hello world. Yeah, Mark. That's it. That's hardcore. So I think one thing that's great about blueprints is it helps communicate exactly how intricate programming is. The fact that this whole graph here is about 20 lines of code we'll just gloss over, right? So this should work now, I hope. Hit play. We're on here. Restart this. We're going to try the original make cube. Oh, I've still got my breakpoint in. Right, resume. And there is a cube. And it's complained about something. Attempted to access index 2 from array. Full func parsing to. Yes. It's interestingly, it still did it. But the error was because it would be trying to get this value when there isn't a default. In fact, the default value of the position is not a parsable vector. So I'm just going to tidy that up. That's what that is. That makes perfect sense. Okay, so what I need to do is look at position and give it a default value, which I hope I can. Position default value of 0, 0, 0, 0. So that should get rid of that. We'll hit play and try again. Now if I say make cube, we should get the cube and no errors. Nice. And then we say make cube pos 0, 0, 200. I like a cube 2 meters above that one. It's crossed. Oh, that's a thing of beauty. That feels good. Little endorphin rush. Does feel good when you get something like that to work, because to get 2 cubes on the screen at the same time, and also to be able to specify the position over the line, feels good. In fact, at this point there's enough there that we can actually make loads of cubes. Make cube pos 200, 0, 200. There's another one. There we are. Make pos 200, 200, 200. And of course you could just sort of then take all of this, and this is the power of the command line. This is why I love the command line stuff, because I can go and do where am I? Make directory Unreal. Okay, I wasn't even doing anything in the directory with files, but now I'm going to do cat into test this and then paste that, and then control D. I now have it in a file, and I can do cat test pipe. Oh, I don't even do cat test. I can just do this and pull in the file from there, and we're just going to have to restart. Currently doesn't support a second connection or restarting, and the connection drops, but this should work, I hope. Ta-da! There you are. Yeah, I've got a level now over the network. Cool. That makes me really happy. So from here, the framework is all ready to add more commands, because obviously I don't have them all in yet, but for position and rotation and all the rest that I might want to do, I'm almost at the point where I can use this in Phi. So probably what I'll do is set this up so that, you know, we have a camera view.
Hello, Dino.
Hello, Hal. You know, maybe something, you know, like this, and there'll be objects in the scene that I can just create from Phi and move in Phi, and all I need to do is implement a very thin layer of networking, just using sockets directly. It will take less time than it took to set them up in here, and the way that Phi works, it's going to really be very quick to connect them together, so that I can show how, when there is, because, you know, Phi is event driven, the tick of the game loop becomes an event. So there will be on tick, or whatever it is. It will be able to specify what should happen. And the first thing I'll probably do with that is it will increment a counter. So that's the frame counter. And then I'll be able to do an expression that says on change frame counter. You know, move the object. And so in that way, Phi will be able to actually make an object move, and what it will do is it will transmit those movements over the network, so that I can work. I know some of you already know. I don't know who's watching, but in case there are people who are not familiar with what the hell's going on here, the Phi programming language virtual machine that I've got will be able to interact with Unreal over the network without me needing to mix the two code bases at all. That's the whole point. That's the nugget philosophy. That's what's called nugget window, is the ability to completely separate different components of a system, even not just sort of separating over an API, but separating over computer systems, over networks, that there is no distinction in the end in the architecture when there's a communication between two modules. It could be running in the same process, it could be running in different processes, it could be running on different machines, it could be running different parts of the world. That is loosely the idea. So you can see the advantages of it. It's like the compile time when I work inside Phi is going to be just like, it's going to compile in a fraction of a second, and then immediately wake up and immediately start communicating with Unreal, and able to manipulate objects really quickly without any loading time, because you know how much I loathe those, right? It's going to be really, really exciting. So I'm very happy we got here, and there we are. That's all it took. It's kind of decorative in a way. I think when it's done, I might just sort of like put it on the wall or something. I don't know. Anyway, thanks for watching. I've got to go now. Thanks a lot, Mike, Tropical, Mark. See you. And yeah, take care, everybody. I suppose these days I sign off with a video. Which one shall we have today? Oh, I know. Let me see. I didn't have these before. But as you know, as you may know now, I make videos from stock footage. So which one? Should we have some Alan Watts? But I just on another note here. Oh, hang on.
And then what about the birds? They deposit their excrements in the bay, and at certain times of year you can hardly see the water for birds. What are they going to do? Have posses going around shooting the birds because they're fouling the bay? What they want in this bay is distilled water with a 10% saline additive for realistic effect.
He's great. I love him. Oh, Alan Watts. Yes, if you talk about sorry, right, that wasn't part of the plan. You can have Alan Watts live now, like 24/7. I think this is a very good service to the world. But meanwhile, what I wanted to do is go to my channel and put the thing to just close off the stream. And so there's one I'm looking for. Do I not have it? Is it not public? Maybe I don't. Videos. Surely I've got it on here, don't I? I don't. Isn't that weird? I was looking for despot measures. I have a video for despot measures. Where is it? Why isn't it on my YouTube? So since I do not know the answers to those questions, I'll have to pick something else. So that one's a bit no, we'll do this one on the cosmic scheme of things. This was my first experiment. This was my first experiment in using stock footage to do video, and the soundtrack of this was recorded on a DeepMind 12 synth, and that's it. Not even using MIDI, just recorded live. I will end on that one. Take care, everybody.